Introduce yourself and your specific role there, and then we'll get into some of these questions.
Sure. So I'm Georgia Dinolfo, and I am the acting deputy director of the Heliophysics Science Division at NASA Goddard. And so I've been involved with, the upcoming mission that we're so excited for many years, and excited to tell you about it.
So tell us what the mission is and what you're trying to accomplish, because most people, the advice is to look away from the sun. You want to get as close as possible, and you're doing it.
Yes, we are. It's actually an amazing, I think, feat of combination of, excellent scientists and engineers coming together to make this actually happen. And so Parker Solar Probe was actually launched in 2018, and it's a mission that is getting progressively closer to the surface of the sun. And December 24th of this year, so right around the corner, we're going to get as close as we can get to the surface of the sun, 3.8 million miles from the surface of the sun. And to give you some context, we're sitting here at Earth at 93 million miles away. So that's really close. What it really means is that we're flying right through the atmosphere of the sun, which we call the corona.
Now, some people recently will have an experience where they were able to see what you're talking about. When we had the solar eclipse, the corona is that outer whitish band. Is that correct? Is that where the Parker Solar Probe is right now?
Exactly. I mean, it's such great timing when you think about it, right? Because we were able to actually view that corona as the moon passed in front of the sun and blocked out most of the light. What you're actually seeing is this beautiful and very structured corona, and it's dynamic too. It's really moving around. There's explosions that you can see, coronal mass ejections. And while we're watching that, we have a mission that's going to fly right through all that dynamic solar atmosphere called the corona. Very exciting time. And it sort of provides scientists with a bookends, right? One is the being able to observe it from afar, and the other is to take all of our suites of instruments and fly them right through the atmosphere of the sun.
How in the world are these instruments able to survive and then transmit back to Earth, being so close to the sun? I mean, this must be engineering, one of the greatest things ever.
I think it's one of the greatest things ever. It's super cool. I mean, we basically have this heat shield in front of the entire spacecraft that is actually providing keeping all of our instruments and spacecraft in the shade, right? And so on one side, closer to the sun, it's 25 degrees Fahrenheit. On the other side, it's 85 degrees Fahrenheit. I mean, it's really an amazing engineering feat. And at the same time, as that spacecraft is orbiting around the sun, it has to actually pivot, right, to keep all of those really valuable equipment in the shade. So that's also like an orbital feat of incredible task that the engineers had to do.
Another thing, aside from the solar eclipse that we've experienced recently, why people might be interested in this story is even here in Northern California, we've been able to see the aurora. And it's been really incredible. And that's partially related to something that you're studying, right? The solar wind.
Absolutely. It's partially related to that. And so basically, the aurora is formed when you've got those large explosions, which we call a coronal mass ejection. So it's a big explosion on the surface of the sun. And often you can see that you have, millions of tons of matter barreling out into outer space. And some of it can actually impact the Earth. And when it does impact the Earth, it can create these beautiful aurora. And very recently, in May and October of this year, we had giant geomagnetic storms that created these aurora that, as you said, reached very far south down south. And typically we don't see them unless we're really up closer to the poles. So it's a great opportunity. We're in solar maximum. And so I think we might have another opportunity to see that.
One of the things I learned about this mission, and I think that this is incredible because, when we're going through school, you reach your upper limit of math at some point. But I think whoever you have working on the math side of things has really done incredible work, because you're actually using Venus to slingshot this probe to get closer and closer, and you have to get all those calculations, because too far away it's not going to work, too close that's not going to be good for the probe. How have you been able to use Venus to do this?
I mean, it really is impressive. And so we're really, every time we swing by Venus, we lose a little bit of orbital energy. And so that allows the spacecraft to kind of sink further, closer to the sun. Yeah, there's a lot of calculations that have to go into getting that right, getting each pass by Venus so that we lose just the right amount of energy to get to edge our way closer to the sun. And of course, we don't want to get too close to the sun. So it's really a sweet spot.
Now, I know not all missions go on forever. There is a timeline for this probe and this mission. What's next in the next year or two or three? Because I imagine ultimately the math won't math anymore, and it will not be able to keep doing what it's doing.
So we're actually going to have our closest approach in December, as I said, and then we're expecting to go around a couple more times, and that's really what we call the primary part of our mission. But as you said, this is amazing engineering, and so this spacecraft is really going to be able to last a long time. So we envision being able to make measurements into the future. And the nice thing too, I think about Parker Solar Probe right now is that there are other solar missions that are being launched right now. One has been launched by ESA that's going to be looking at the sun, and it has a coronagraph. And then we have another mission called Punch that's going to be launched in April, and that will be looking at the sun's atmosphere in 3D. So, all of these things will be helping us to better understand how the sun works.
And my final question, a lot of people are intrigued, they're interested, they've all learned a lot by watching this, I hope. But a lot of people will want to take it back to themselves. This is human nature. What will the what you learn, the data, and so on, how could that affect people's experience going forward in their daily life?
Well, sure. I mean, there's a number of ways. I mean, for me, I like to think about the fact that, we're using this mission as our local laboratory. And so it's going to inform us about how our star works. But, if you're looking at astrophysics missions, then we're going to want to start to take what we've learned, those lessons learned, and apply them to other stars in our galaxy and how other planets around those stars may or may not be habitable. And it'll also affect our everyday lives because we can get better at predicting those big explosions on the sun. And of course, that means we can better safeguard our space assets and also our astronauts as we move to the moon and maybe even to Mars.
Absolutely incredible. Great information. Great job on the mission. And I guarantee somebody watching this will say, you know what? Heliophysics. That's what I've been searching for. I want to be like this person. And this is what I'm going to do because the work that you're doing is incredible. And I'm so happy that it's been successful so far. Thank you so much.